This lesson will continue with Arduinos, but now we're going to look at inputs. So we're going to look at analog read, serial print, digital print. Analog read. We will be using photocells, also known as light-dependent resistors. The resistance decreases as the light source increases. So if you put your hand over this type of resistor, you will get more resistance. Remove your hand or add light, you'll get less resistance. Hardware assembly, you'll need a photoresistor, an LED, some wires, 330 resistors, which we used a lot of, and a 10K resistor. All right. Now, take a moment to go ahead and build this circuit. Notice we have the photoresistor, we have as something, and we have a 10K resistor, a 10K ohm resistor. That's unique. This is a 330. Now, let's look over here on our board. We're going from the 5 volt to ground. They're providing power down here. We also have under A0, that's your analog. Remember your analog pins? That's going all the way up to here on the one leg of the resistor. When you refer to this, when you program, make sure it's a capital A. Finally, we have pin 9 going to this other LED, the positive leg of the LED. Notice also something we want to point out. In this case, A0 is an input, 9 would be an output. That's going to turn on this LED. So because this is the hot coming from the 9, when we program it, we won't do it in the beginning, but we'll do it towards the end of the lesson. This 9 goes to the positive leg of the LED. The negative leg, or the cathode of the LED, is connected to the 330 resistor, which is connected to the ground. Let's look at the photoresistor. The photoresistor, one leg is connected. There's no polarity on a photoresistor. One leg comes off the hot, this 5 volts. Then you have a 10K resistor here. And then you have this green, which goes back to your A0, or analog 0, which in some ways it's going to register the value off that photoresistor. That's its main function. But you can almost think of it as a ground too. So the hot goes this ground, goes the resistor over here. You may say to yourself, why do we ever have to have this resistor here then? Well, you have this resistor here, so if you do not turn on the A sub 0, it's not acting as a sensor. This will, because this is building up current, you need a way to discharge the current. That's what this resistor is using for. It's a 10K resistor right there. We use a 10K, so it has high resistance. So it's going to, most of the voltage is going to want to go back in to A sub 0. Otherwise, if A sub 0 is not available, then it'll go through this 10K resistor back to the ground. If you don't do this, it almost will end up creating a problem for your Arduino. This is also, remember, is a 10K resistor. I can't stress enough. You don't put a 10K down here with the LED, you would never see the LED. There's your parts, your A sub 0. All right, programming this. Remember, all Sketch programs require void setup and void loop. It will not run otherwise. But that's all you do need to run. So you could literally load a program that just said void setup, void loop, put in the proper containers, and it would run. Wouldn't do anything, but it would run. In this case, we're going to look at just the input for A0. So we're going to make pin mode A0, notice that A is capitalized, comma, input, semicolon. Remember we've been doing, say, pin 1, output, pin mode 3, output, comma, output, pin mode LED pin 1, comma, output. This is now an input because that's the function of this. Next, under void loop, we define a variable, LDR, light detecting resistor. Whatever we read out of the analog read, and yes, there is a digital read, analog read, capital R on that same word, from pin A0, remember we just made that the input, assign it to LDR. Assuming that you typed everything correctly, your code is working, yet nothing seems to be happening. Essentially, we don't know what the Arduino is doing with the data it's receiving from the LDR or photoresistor. That's going to A0. We have no idea what it's doing right there. So we need to add a little more code. We're going to use this program called serial print. This allows the user to view the data the Arduino is processing. Incredibly useful tool. Like brain surgery, it allows the user to get a direct look inside the Arduino. It can be quite helpful in informal troubleshooting. So you have serial.print parentheses variable parentheses colon. We'll print out the given variable, but it will run across the screen horizontally. If you do serial.print ln, notice it's ln variable, then it will print out the given variable, but add in, which stands for line, the ln, the added ln stands for line, gives the data line breaks. In other words, the data will be printed out vertically in a much more readable fashion. You're going to get a chance to try these things. So again, it would be serial print parentheses, in our case LDR parentheses, serial print line parentheses again LDR in caps, and of course semicolon after it. So that's what it looks. You have to tell the serial monitor. This sets the data baud rate in bits per second, baud, for serial data transmission. So this is just how you're sending information back to your computer. The default is usually 9600. So you have serial, capital S, dot begins 9600. Add this to what you've already had so far. And then down here, put serial.print ln, parentheses, LDR, parentheses, semicolon. Remember, you should be saving your programs. As we keep adding to this program, you want to save it. So if you're saving it by inputs, maybe the first program you write is input 1, then input 2, or give it some names. This way, if you make a change and it adversely affects your program, you don't have to start all over again. And these do crash. Computers do crash in this. So if you got to run that, you need to click on this serial monitor button. So once you run this code, you just print it out there, you upload it, then click on serial monitor, you'll see a screen. Let me go. I've got to go a little farther ahead to show what the screen would look like. You can see where we're going. Imagine it would just be a series of numbers. Don't worry about LDR equals, or certainly not the button. We haven't gotten there yet. But you would see this. All right. So go ahead and pause. Let's see here. So we're right at this point. Go ahead, put the code in, pause, get it to run. Make sure you plugged your Arduino on to the before you started up the Arduino software. Make sure if you're a PC, either your COM3 or COM4 on your port. If you're a Mac, it just needs to say USB on it. Don't try to hook up, say, to the Bluetooth. All right. Now, it does work when you run it. The numbers are running vertically incredibly fast. The speed is so fast that makes reading it just a little bit unusable. How could we slow it down? Think about this and then see if you can answer it before I tell you. How can we slow it down? We just drop in a delay. It's going to cause right here under the void loop just a quarter of a second delay, 250 milliseconds. How slowly did we make the resulting data run? I hope you said a quarter of a second, 250 milliseconds. Everybody's numbers will be different. Why is that? Well, if you were talking to your friend and you were doing this, and you're running from two different locations, their house and your house, you would find out that the light at their location would be different than yours, and therefore your photoresistors would read differently. And plus the photoresistors themselves have differences in them. We're going to add a little more formatting for our serial monitor window. That was the window I showed you that had the numbers running down vertically that you should be seeing. It goes away every time you upload the program. So, okay, so save your program. Let's get it a new number, and now we're going to add this to it. Okay. What this is going to do is add this line above the serial print line LDR, which is just what you added. Now we're adding this line right here, serial.print LDR. So that when you see the quotation, that means literally LDR, not the variable LDR, which is a number. This is going to be literally a label, LDR space equals space quotation. So you had a quotation aside, parentheses, semicolon. Why is this new line serial print instead of serial print line? So that, think about that a second. The reason it is we want this data, serial print line, which is going to, every time this prints out, it's going to go to a new line, be on the same line as this. Okay? So that way you'll see on the screen LDR equals that value. So let me go back down and show you that real quick again. It's not show you button or zero, not going to show you that now. But what it is going to show you is LDR space equals and then the value. LDR is going to stay constant, but the values change every so little bit. All right? All right. Now, every time the code sees print line, it's like hitting the enter key on your keyboard. Anytime serial print is used, there is an automatic delay in the code that you cannot see. This is simply because it takes time out of processing the data to print the screen. And why are we saying it takes a little bit of time? Because you can't see the difference. If you're doing any kind of sampling, you got to be careful, or at least take that in consideration. All right. So if down the road you start getting the more impressive projects, then you're going to need that. Okay. All right. Digital read. Digital read. All right. Digital read. Now, we should have named your program, give it a new name. We're going to add some stuff to your breadboard. This is really important, and we're going to get into a pull-up resistor here. This is particularly important. We're going to add this your button. It's going to come from pin 8. Notice this LED's right there is in pin 9. This is in pin 8. It's in this top pin. The same top pin on the other side, this 10K resistor is going to the ground, right where my green arrow is. This bottom leg goes to the hot, back down to our 5 volt. Why is this important that we do it this particular way? Well, remember, on input pins, if we think of them kind of acting like a ground at times, this is connected. These pins are connected all the way over here. This hot pin is not connected to this pin necessarily, but it is connected from here to this side. This pin is connected from here to this side. When I press the button down, the current now is a place to go. So it goes from hot over to the button, across here, down to pin 8. And because this is a very high resistor value here, it's all that voltage, almost all that voltage is going to get across. So it's going to be a very high, distinct reading. This really helps microcontrollers work because you want it, if this was lower voltage resistor here and only part of the voltage was going here, it would do what is called floating. Sometimes it would say it was true, sometimes it would say it's not. Because remember, this is digital. This is going to be zeros and ones. This photoresistor was analog. It can be a whole range. This is going to be 0 or 1. And it's hooked right there. All right? Now let me show you the same thing on 1, 2, 3. All right. I've gone to 1, 2, 3D circuits, and I'm going to demo what we're talking about here. You get a sense of how this is working. Okay? So, I'm coming off my 5 volt and my ground on this side. I flipped it. Here's my resistor on the ground, connected on the same line as pin 8. So resistors here, resistors here. I can also, which is a great time to show you this on 123D circuit, I can simulate the actual code and everything. So there's my code editor, and I'm going to put up my serial monitor. All right, so let's start the simulation. Now, with it running, I can see that I'm getting nothing but zeros. When I press the button, and if you want to try this at home, as they say, you press the button, you're going to see a little green light goes on. That tells you that you press the button down. I'm getting the value 1. So what's happening here is I set pin mode 8 to input. I do my serial begin at 9600. The loop runs over and over again. Again, we know that on void loop. But in there we have the integer button, so that's our variable button. It does a digital read. Remember we used analog read? Digital read to pin 8. There it is, pin 8. Serial print, line button. It keeps going down. Now, in the other one, remember we had the pin 8 at the top of the button, and we had the ground at the top. It doesn't matter that. What's important is pin 8 is on the lower, and the resistor is on the lower. Right here. All right. And so that's the important thing. And it's a 10K ohm resistor. All right. So again, when I'm pressing that green light's pressing the button down. If this wasn't pressing it down, I get a value of 0. None of the voltage. When this is 0, what's happening is heat comes to the button, goes down this leg, travels back. This terminal, the digital pin 8 is reading nothing. When I press this now, the current can go through here, back down to pin 8. All right. Okay, I'm going to take a moment, pause this. If you can build this, if you want to build this and run it on 123D circuit, take a moment to do it. Now, let's go establish, let's write the code now. After you've built your button, let's make sure you built this, physically built it. Then, let's go ahead and get ready to program it. The first thing I want to ask you is, what's the difference between analog and digital? Again, remember, analog, think temperature. It can be a range of values. Digital's on or off. All right? What kind of data will be coming from pin 8? Analog or digital? I hope you said digital. All right, so here we're going to our input. Now, again, I would save this, and I would save it, put digital in the name so you remember this. But save what you had before. You don't have to keep creating the same thing. We're going to add pin mode 8 as an input. We're going to do space integer button equals digital read 8, serial print LDR, and serial print button. And what this does is, there's the input, we define it. There's our variable button, and it's reading pin 8. And now we're going to add to our 2 columns, so it'll print out. So we have serial.print LDR, serial.print LDR, so that's the value. But now we do another serial print quotation. Look how big space. Well, that big space is for the LDR, the analog LDR. And then button equals, literally button equals, serial print line button. See how we have that? Also notice on the serial print up here, we changed it. The last one's got the LN. These two and this third one, they don't have the LN. You want them all in the same line. And then we have a delay. Take a moment to write this code. And then the amount of space is just to keep the data more readable. Remember, this is still on the same line. And finally, the line break is added there. Here we go. There's LDR 572, button 0. So it should be reading something. Your LDR values may be different from mine, but when you're not pressing the button, it should be 0. When you're pressing the button, it should be 1. When you're pressing the button, it should be 0. When you're not pressing the button, it's 0. When you're pressing the button, it's 1. One more time. Now pressing the button, value is 0. Pressing the button, it's 1. Now, and this is a final look at that code right there. Okay? So you should have had this. If you need a moment to write down, take your time, go ahead and do it. Sometimes you start adding all these lines, it gets a little bit more difficult to read your breadboard. So as general rules of thumb, yellow is for input, red is for power, black is for ground. We're about to hook at that LED up. We would change that for orange for output. So your breadboard might look something more like this. There's your hot, your ground, your red, black. Here's your output to the LED pin. We're going to control that. Your inputs to pin 8 and into A sub 0. Okay. Now we're going to add, now let's save this, and you can put analog digital LED or something. You're going to save what you've done. I want you to rename, give it a new name so it can even farther. Okay? Now, in this case, we're declaring the LED variable again, LED equals 9, though you could just use 9 as we did. Here we used 8. Here's using a variable, so we're giving you different ways to do the same thing. All right. Pin mode 9 is output. So this is saying, hey, LED, these two are inputs. Now make this as an output. All right. And that's going to be an output. All right. Now we're going to add inside the loop. So from now on, there's your void setup, and which we won't refer back to on the next slides. Here we go. And here's what's called an if-then. Remember that we did this in Scratch, or you may have done this in Scratch. If you've done Scratch, you've used an if-then statement. And that is, if you're touching, the ball touches the side or the sprite touches the side, bounce back. We use that in Scratch. Here it's if, and just like in the loops and the functions, it's if parentheses LDR less than 200. So if you're adding a value of less than 200, no semicolon here. Left container, digital right LED high, semicolon, container, else, container, left, digital right LED low, semicolon, container. So this is saying if LDR is less than 200, what's going to happen? Think about it. If the LDR value is less than 200, and you may have to change your experiment with your values to get it to work. If it's less than 200, well, LED set to high. If it's not less than 200, if we didn't put this else code, what would happen? Well, nothing would turn the LED off. So we do else. So if it's not less than 200, else set digital right LED to low. Also, let's add the and or command. All right. And again, let's remember our Scratch backgrounds a little bit here. If in Scratch, if you said if the score is less than 200, then do this, else do that. So this is what you're writing in this code. If LDR is less than 200, notice it's again like the for and other our loops and our functions. There's no semicolon after that. It has a container. Two containers. In this case, it would say digital right high. And you could have what else you want at that point. Else, digital right low. All right. If LDR is less than 200 and the button is 1, digital right LED high, else digital right LED low. So this is adding the feature of and. So if LDR is 200 and the button is 1, notice it's not equal 1. It's equal 1. So that's testing for it to true. If you just had equals 1, you'd be assigning 1 to that variable, and that's not what we wanted to do. Then we have LDR less than 200, or, that's what this represents, button is 1, then it's high. Now, the thing about AND, you have to have it both less than 200 and the button being pressed. With OR, it can be either one. So OR is much more expansive of a search, and is a much more narrow search. And this symbol, this / symbol, is created with a shift / key. So hit shift in this key, you'll get one of these, and then do it a second time. All right? To get this look right here. Okay? That's not always very obvious. It's right on the edge of your keyboard, right next to your containers. All right. So when we put this change, when will this come on? When either one of these two things are true. When your LDR is less than 200, or pick a value if you want to make it 400, because the way your light is in your room, you can go ahead and do that, play with some different ideas. Or if I press the button, so either one of those things will be true, it'll come on. If you try switching the AND and watch what happens. So go ahead and try those two things. And again, you're just try, make sure you're saving this, and you can try out different code ideas. Because you can always save this program, and then later on when you need to do an if-then statement, you can come back to it and say, oh, that's how we did it. All right? Okay. This is what I have for inputs. The next thing we'll be doing down the road is potentiometers and servos, which is very, very interesting. But for right now, that's inputs. Please rewatch the video again if you have any more. First, rewatch the video again. All the code's there. If going through listening to this you missed something, and if that doesn't work, feel free to email me. All right. Thank you.